I am Derek Gottwald from the R2T2 team of Sense Enterprise. What is SENSE? SENSE stands for Strategic Education Through Naval System Experiences. As an enterprise, our projects focus on real-world naval systems applications. Our sponsors range from university researchers looking to gather data and test devices to private companies looking for creative solutions that pertain to our enterprise's expertise. This presentation showcases the projects that our enterprise has worked on over the past year. These projects are known as the Marine Energy Collegiate Competition, or MECC, Naval Engineering Education Consortium, or NEEC, Robust Autonomy in an Underwater BlueROV, otherwise known as RAUB, the Rim Run Thruster Team, or R2T2, Targeted Retrieval of Autonomous Craft, or TRAC, Ice Melt, and HF Radar. These teams all have much to say on their progress this past year.
Hello, my name is Jayden Colbert. I am currently the project lead for MECC, or the Marine Energy Collegiate Competition.
Hi, my name is Laura Hall, and I'm a current project engineer for MECC. MECC is an annual startup-themed competition hosted by the National Laboratory of the Rockies. It's focused on creating a marine energy converter for an economically feasible market. To identify their market, our team conducted community outreach events, industry interviews, and current market research.
This year's team is developing an attenuator to power isolated and remote communities in the Great Lake region. The design utilizes rotational motion of the waves between two bodies to generate electricity. Deploying these attenuators would support the communities with clean, reliable electricity without the need of fossil fuels. The team tested their design in the Michigan Tech Wave Tank and collected testing data. The team will then present their findings in Portland, Oregon this upcoming May to the Department of Energy and to the National Laboratory of the Rockies.
Hello, I'm Nicholas Wyatt. I'm the team lead for the NEEC Surface Autonomy project. In this project, we're working on outfitting a commercially available research vessel, a Blue Robotics Blue Boat, with a suite of sensors and a suite of edge computers that allows it to create a robust localization map and then perform path planning and other objective planning off of that so that we're able to make the boat navigate intelligently in multiple different marine environments.
Hello, my name is Jayden Chow, and I was the RAUB project lead for the fall 2025 and spring 2026 semesters. My team of 6 has been working with the Blue Robotics BlueROV 2 to develop full underwater autonomy using single beam imaging sonars and DVL. For the past 2 semesters, my team has been developing a path planning algorithm, a path following algorithm, a collision detection function, a Kalman filter to reduce the odometry error, and a code base to extract the sonar information for implementation into a localization algorithm. These have been tested in the Portage, the MTU Wave Tank, and the SDC pool facilities to evaluate their performance and identify areas for improvement. In future semesters, the team hopes to combine all of them together into one cohesive working autonomous system.
Hello everyone, my name is Nolan Dahlstrom from the R2T2 team, which stands for Rim Driven Thruster Team. Our goal is to gather data on a new rim-driven thrusters that are given to us so that they may be implemented into other projects. This semester so far, we have designed and constructed a thrust stand for testing in the MTU Wave Tank. The thrust stand uses a strain gauge connected to the opposite end of a pivot arm using a line and tension. The strain gauge should record a force equal to the thrust and motor outputs at a given pulse width.
Alright, so we are Targeted Retrieval of Autonomous Craft, or TRAC, and our sponsor is Ocean Infinity, and what we're doing for them is modifying their nose cones for the autonomous underwater vessels they have, or AUVs. And what we're doing is a drone's going to fly around with a rope, catch in this little rope catch here, and then as it's pulled back to a mothership, it will close shut through just the physics of it being pulled. So that way this stays shut, the rope stays inside of it as it gets pulled up onto a mothership.
We are part of the Ice Melt team, which is a 1-year-long project with General Dynamics Electric Boat. They tasked us with designing a testing apparatus and standard operating procedure for experimental ice melters, which will be deployed from under the ice for Arctic research. This semester, we tested and built a table with an aluminum arm, which is inserted through a hole but operated from above the ice. The arm is equipped with hydrophones and a distance sensor, and an ice melter, which is deployed from the end. This semester, we went through 2 rounds of testing off the docks of the GLRC to gather ice melt data, and moving forward, we will be making design modifications and working with our sponsor on progressing this project further next year.
My name is Olivia Rake. I'm a part of the HF Radar Validation Team on the SENSE Enterprise. The goal of the HF Radar Validation Team is to design, build, and deploy a set of drift buoys to validate and improve HF radar wave data integrated in the Great Lakes Observing System. So far, our prototype consists of a Nalgene brand bottle with a 3D printed support structure inside, along with an IMU and a Walter ESP to collect GNSS data, as well as a power source. This semester, we've improved the accuracy of the data, integrated the data together, and partially processed it.
We would like to thank our advisors, Dr. Timothy Havens and Dr. Tania Gonzalez, who have been indispensable to our enterprise over the past year. And to our sponsors, who we would not have so many great teams without.